Dmitry Mendeleev, a Russian chemist, 1834 to 1907, was born at Tobolsk, Siberia. He studied science at St. Petersburg and graduated in 1856. In 1863, he was appointed to a professorship, and in 1866, he succeeded to the chair in the university. Mendeleev examined the relationship between the atomic masses of the elements and their physical and chemical properties. Among chemical properties, he concentrated on the compounds formed by the elements with oxygen and hydrogen, as they were very reactive and formed compounds with most elements. By analyzing these compounds, Mendeleev believed that atomic mass of elements was the most fundamental property in classifying elements. He arranged elements in the increasing order of their atomic masses and found that the chemical and physical properties of elements showed repetition after certain intervals. He arranged known elements in the increasing order of their atomic masses in horizontal rows. He encountered an element which had properties similar to the first element. He placed this element below the first element and thus started the second row of elements. Proceeding in this manner, he arranged all known elements according to their properties, thus creating the first periodic table containing 63 elements known till then. This law is known as Mendeleev's periodic law. It states that the physical and chemical properties of elements are periodic function of their atomic masses. The tabular arrangement of the elements based on the periodic law is called the Mendeleev's periodic table. Main features of Mendeleev's periodic table. The horizontal rows in the periodic table are called periods. There are 7 periods. These are numbered from 1 to 7. Properties of elements in a particular period show regular gradation from left to right. The vertical columns in the periodic table are called groups. There are 8 groups numbered from 1st to 8th. Group 1st to 7th are further divided into A and B subgroups. Merits of Mendeleev's periodic table. Mendeleev was the first who successfully classified all known elements. Mendeleev kept some blank places in it. These vacant spaces were for elements that were yet to be discovered. He also predicted properties of these elements even before they were discovered. Later, they were found to be correct. The predicted element was Eka boron. Actual element discovered later was scandium. Another predicted element was Eka aluminium. An actual element discovered later was gallium. And he also predicted another element, Eka silicon. Actual element discovered later, similar to it, was germanium. Let us now compare the properties of Eka aluminium, Ea, and gallium, Ga. Atomic weight of Eka aluminium predicted was about 68, and that of gallium is 69.72. Density of solid predicted of Eka aluminium 6 grams per centimeter cube, and that of gallium is 5.9 grams per centimeter cube. Melting point of Eka aluminium predicted was low, and that of gallium is 29.78 degrees Celsius. Valency of Eka aluminium predicted was 3, and that of gallium is 3. Method of discovery predicted of Eka aluminium was probably from its spectrum. Well, gallium was discovered spectroscopically. Formula of oxide of Eka aluminium is EA2O3, its density 5.5 grams per centimeter cube, and it is soluble in both acids and alkalis. Formula of oxide of gallium is Ga2O3, its density 5.88 gram per centimeter cube, and it is soluble in both acids and alkalis. So we can clearly see that almost all the predictions of Mendeleev clearly match with the element discovered later. Friends, when noble gases were discovered later, they were placed in Mendeleev's periodic table without disturbing the positions of other elements. Demerits of Mendeleev's periodic table. Hydrogen resembles alkali metals as well as halogens. Therefore, no fixed position could be given to hydrogen in the periodic table. Isotopes of same elements have different atomic masses. Therefore, each one of them should be given a different position. On the other hand, as isotopes are chemically similar, they had to be given same position. At certain places, an element of higher atomic mass has been placed before an element of lower mass. For example, cobalt, that is CO with atomic mass 58.93, is placed before nickel, Ni, with atomic mass 58.71. Some elements placed in the same subgroup have different properties. For example, manganese, Mn, is placed with halogens which totally differ in their properties.